Minerals are the building blocks of the Earth, but did you know that minerals themselves are commonly made of shared building blocks? We can visualize the crystal structures of these minerals using a series of 3D printed building blocks called TotBlocks. In this video, we'll explore the crystal structure of Kalifersite, which is named after its chemical formula.
Kali refers to kalium, Latin for potassium. Fer refers to ferrum, Latin for iron, and Si represents silicon. Kalifersite is an extremely rare and obscure mineral that is only found on the Kola Peninsula of Russia, but its crystal structure is particularly interesting from the perspective of modular mineralogy. The crystal structure of Kalifersite can be considered as alternating double and triple chains of TOT rod modules, which are linked by palisepiol type linkages, or in other words, it is a combination of palygorskite-like and sepiolite-like modules. Now, we'll take it apart. To learn how to build the component TOT modules of this structure, take a look at the Assembly of TotBlocks video in this series. There are differences between the modules in Kalifersite versus those of palygorskite and sepiolite. For example, in the double chain sections, we see that there's a site missing, so compare that to that of palygorskite. And so instead of getting the typical Z5 module that we get in palygorskite, we get a Z3 module. Similarly, in sepiolite, there's also site missing, so we can see that over here we've got 8 different sites, and over here, or actually 4 different sites, and over here we've got 3 different sites. So again, we have a Z6 module instead of a Z8 module. To construct the Kalifersite structure, 2 double chain with TOT modules, which are constructed using Z3O+ modules, and 2 triple chain with TOT modules, which are constructed using Z6O+ modules, are needed. So the T- module of 1 double chain with module is connected to the T+ of a triple chain with module. Then the T+ of the same double width chain module will be connected to the T- of the triple chain with module. And finally, another double chain with module will be connected to the bottom of the series. And this pattern can be repeated as necessary to extend the structure. Here we'll show another iteration of that structure. In the crystal structure of Kalifersite, silicon fits in the tetrahedral or red sites, and iron 3+ as well as some vacancies will fit into these green octahedral sites. There are also potassium and sodium and water sites that are found within these channel spaces between the TOT modules. In this video, we've explored how the modular relationships between palygorskite and sepiolite can be used to describe the crystal structure of Kalifersite. We've also looked at the differences between the structure of Kalifersite versus palygorskite and sepiolite, namely the use of Z3 and Z6 modules in place of the Z5 and Z8 modules, which are normally found in palygorskite and sepiolite, respectively.